Okay, section 5.4, complex fractions. I love this one because it shows uh, a concept that makes something that looks confusing actually pretty simple. So 5.4, complex fractions. The key, multiply every one of them, every fraction that is, like considering that as one fraction, two, three, four different fractions here. Multiply every single one of them by the LCD of all of them. Now, the other route to do fractions is you would get an LCD on the top, work through that, an LCD on the bottom, work through that, then you're going to flip and multiply. Well, you might as well do the least common denominator of all of them, and then you don't have to flip and multiply. You'll see how it works out. I show the Y in class. In here, I'll just show how to do it. You can pause this again if you want to look at any of these more in depth. And there's different ways to do them here. When you get separate fractions on the top and separate fractions on the bottom, multiply everything by the LCD. Example 3 shows a case of if there's only one fraction on the top and one fraction on the bottom, then what you could do it this way, LCD of both of them. There's only two, but LCD of both of them and get your answer. Or in a case like this, you have one fraction divided by one fraction. So you can always do fraction, the numerator times the denominator reciprocal. Okay, and I'll do one of those as an example. And then example 4, we had an x and an x squared. That just means x squared is our LCD, least common denominator. Multiply 1, 2, 3, 4, 5 fractions by x squared. And then example 5, literally just a 3. When there's a whole number, you can just leave it out till the end, till you know what you're doing, and then incorporate it. Okay, so that's my 5.4 notes. Let me work a couple so you can see what's going on. I'll get my green pen to help out. I chose number 7 to start with because it's our simple x on the bottom, x on the bottom. This is a whole number, so it's whatever we want it to be. So my LCD in this case is x, and we'll just say x over 1 to go that route. Now, and well, I'll put it over here to the right. You can treat it as x plus 1, or you can just say x. It depends on how your mind works, doesn't really matter. So when we multiply our numerator, and this is my numerator, this is my whole denominator. So multiplying the fraction up here by our LCD leaves us with 1. Now they don't go away. One common mistake is people cancel them out and they think of it as 0. It's not 0. 1 goes into 1 once, x goes into x once, 1 times 1 is 1. We have 1 on the top. It's like a placeholder to show us we have a fraction. Then down here, I'm multiplying x by 1. So I have x here, x, 1, 1, same thing as the top. They cancel out. I had a positive, I was adding, plus 1, I'm done. That's it. Now, somebody could have taken 1 over x, and then they could have made this an x and incorporated this piece, then flipped and multiplied, and they get the same answer. This method of complex fractions makes the whole process a lot simpler. This one I won't do both ways. I'm going to do this one the quicker way. Now, when, again, like I said, when you have separate fractions, like down here, if there's 3 or 4, but basically if there's more than 1 on either the numerator or denominator, then you want to do the LCD route. Here, I have 1 fraction on top, 1 fraction on the bottom. I do have to factor. They give me pretty easy numbers to factor. Now, what this is saying is this whole piece, which is this one, divided by this piece. So what I do is I multiply by the reciprocal. So I flip these. and I have a 9x squared, which happens to be a perfect square. So this is what I have. And now, once you're multiplying, you take something in the numerator and look for anything in the denominator, because these are all multiplied together. The other way to write this, I'm just going to rewrite this for clarity. It's this quantity times this quantity. You can always rewrite if it helps you see what's happening. There. That's what this means. Multiplying two fractions, once they're multiplied, everything on the top multiplies together, everything on the bottom multiplies together. Everything on top, or anything I should say, is fair game with anything on the bottom. So you can just start, you can go with whatever you see first, or you can go left to right. 3x plus 1. Is it down here? It sure is. Right there. That cancels out. X minus 7. Is it down here? Yep, right underneath it. So I have 1 on top, and then I have an x plus 7 times 3x minus 1 on the bottom. And I'm done. That one was pretty simple. Now I'll do one more that has 4. Now here, because there's 1, 2, 3, 4 fractions involved, I will multiply by the LCD, and I will multiply all of them by the LCD. In this case, I should have left myself more room over here. And assume that's on the top. What I'm doing, and hopefully I write it right, I'm trying to write it correctly, I should say. My LCD, when I have quantities, is just all the quantities together. I have an x plus a, an x minus a. Same thing on the bottom. My LCD is x plus a, x minus a. Now don't distribute those. Don't multiply them together. Leave everything factored out, because that's what helps us see what we're going to cancel. So when I multiply this first piece, you'll see my x plus a goes away, and I'm left with, I'm left with x minus a here. I'll put it in parentheses. Plus, well then here my x minus a goes away, and I have, I'll put them all in, I'll make it quantities. I'll make them all quantities, so it makes a little more sense. X plus a. Then, sorry. Okay, then I'm going to take my x plus a here, and I'm going to be left with x minus a. Then I'm subtracting, which is kind of why it's good to keep quantities, so you can see you're subtracting everything. And I'll wait, I'll clean this all up later. I'm just going to show what cancels out. My x minus a cancels out, and I have x plus a, but I'm subtracting. So this should have been up here. I didn't leave myself, this should have been up here. I didn't leave myself room. But you can see multiplying by the LCD, it's like what I discussed in an earlier section. You're basically taking what's missing and multiplying the numerator by it, because this bottom piece will drop out. So now I clean this up, and the top is x minus a plus x plus a. And then I have x minus a, although it looks like a 9, that's an a, minus x minus a. So my a's up here cancel out. I have 2 x's. Down here, my x's cancel out. I have 2 a's. I can make that a negative. I can make that a negative because it's a negative on the bottom. Doesn't matter where your negative is, you can just write negative whole fraction, because if it's on the top, the whole thing's negative. If it's on the bottom, the whole thing's negative. So my 2's cancel out, and I'm left with negative x over a. That's how we do complex fractions. Simple concept. You get the hang of it, and these become pretty easy. If you don't get the hang of it, you can always go the long method and get an LCD on the top and LCD on the bottom and then flip and multiply. But this gets rid of the flip and multiply because you're essentially taking away when you're doing this step. Okay, hopefully you enjoy that. We'll go to section 5 in a little bit. Whoops.